Hi everyone, I'm Devi, and today I'll be presenting my project on Lynn Canyon Park and Suspension Bridge. So let's get started. First, I would love to discuss the geological or geographical history of the Lynn Canyon, which basically is the history of how this landscape came to be. So, the physical landscape of Lynn Canyon began forming during the last glacial period when the Cordilleran ice sheet covered much of southwestern British Columbia. Here is a diagram that details the Cordilleran ice sheet. Massive glaciers eroded the landscape, deepening valleys and exposing resistant bedrock while transporting large amounts of sediment, which were also visible during our field trip. As the glaciers retreated approximately 14,000 to 11,000 years ago, they deposited unconsolidated material, including sand, gravel, till, and boulders throughout the valley. These glacial deposits form much of the loose sediment that is still visible in Lynn Creek today. After the deglaciation, meltwater and river flow from Lynn Creek became the dominant geomorphic forces. Over thousands of years, the creek eroded, soft glacial deposits progressively cut downward into resistant granite rock, which was also visible during our field trip. And these these forces cut through this granite bedrock through hydraulic action and abrasion. This long-term erosion created the steep canyon walls, plunge pools such as the 30-foot pool that we visited, gravel bars, which are basically bars that bar like structures close to a water body or a river that are made of primarily gravel, and terraces, which are higher elevations, and floodplains observed at the field site today. So the formation timeline would have looked something like this. So glaciation carved and deepened the valley. Glacier retreat deposited sediment across the landscape. Lynn Creek incised into or cut into glacial deposits in bedrock, and ongoing erosion, sediment transport, and flooding still continue to reshape and change the physical landscape of the valley. Now, I would love to discuss why Lynn Creek is so special and why it's geographically unique. So, the Lynn Creek or the Lynn Canyon contains two strikingly different landscapes: a broad, sediment filled valley upstream and a narrow, steep walled bedrock canyon downstream. This makes Lynn Canyon unusual because if you know rivers, they typically widen valleys over time. Geologists therefore believe that Lynn Canyon has occupied, so the Lynn Creek has occupied the canyon relatively recently because, as we know, it's not that wide, it's quite thin and stream and steep. Let's move forward. So now I would love to discuss the main processes that have caused change to the physical landscape of the field site and continue to do so. First would be glaciation, which is the process that originally created the original landscape. So here is a diagram that shows the Cordilleran ice sheet or glaciation. So, to understand the Lynn Canyon, we need to go back to the last ice age. During this period, the Cordilleran ice sheet covered much of British Columbia, included the North Shore Mountains. Sheet reached the elevations of up to 3,000 meters above sea level. These glaciers were the original forces that shape the valley today. As they moved, they eroded mountain valleys, smoothed bedrock surfaces, and transported enormous amounts of rock and sediment. When the glaciers eventually melted, they deposited glacial till and along with which consisted of sand, gravel, silt, and boulders. Evidence of this glacial history can still be observed at the Lynn Canyon, especially in the loose sediments upstream of the 30-foot pool and in sediment layers visible in cliff exposures. Next would be the post-glacial sea level change. So after glaciation, the changes that occurred in sea level from melting of the glaciers. So here you can see a diagram of a river delta. Deltas form as rivers empty their water and sediment into another body of water, such as an ocean, lake, or another river. So this process of change in sea levels explain why the erosion started. After glaciers retreated around 13,000 years ago, Lynn Canyon still looked very different than it looks today. Sea level was approximately 200 meters higher than it is now. Streams flowing from the North Shore Mountains entered this higher sea and deposited large amounts of sediment, building extensive deltas, which we can see in the diagram. These sediments buried much of the older landscape, including former valleys, and as sea level gradually fell, streams gained more erosive power and began cutting downward into these deposits. This change in drainage conditions was crucial because it set the stage for development of the modern Lynn Canyon that we see today. Now moving on to river erosion and downcutting. So this kind of river erosion where it downcuts is also called fluvial erosion. Once Lynn Creek encountered bedrock, its path became fixed. So the creek began to let down onto the rock. This meant that the river could no longer easily erode sideways. So most of the erosion instead became vertical, cutting deeper into the bedrock. The main erosional processes here are hydraulic action, and where the water pressure forces into cracks in rocks, and abrasion where transported sediment grinds against the canyon walls and bed. Over thousands of years, these processes carved the steep-walled canyon that we see today. And here you can see a diagram of this hydraulic action and abrasion, or fluvial erosion, as I would like to call it. Let's move forward. So, now I would like to discuss one of the several stops in our field trip, which was the 30-foot pool. So the 30-foot pool is the place where water moves out of the narrow canyon into broader creek bed, and the river has created a beautiful green pool of water. So the 30-foot pool provides one of the clearest examples of active canyon formation at Lynn Canyon. During our field trip, we observed that upstream, Lynn Canyon flows through loose glacial sediments in relatively broader valley. However, at the 30-foot pool, the creek encounters resistant granite bedrock, and the channel narrows dramatically. Because the same amount of water is forced to flow through such a smaller space, water velocity increases significantly. This increases turbulence and erosive power, allowing hydraulic action and abrasion to carve a deep plunge pool and steep canyon walls. Now let's move on to sediment transport and deposition. So the Lynn Canyon continuously moves sediments. It does not only erode the landscape, but it also transports these sediments. And during our field trip, we saw different kinds of sediment materials ranging from fine sand to large rounded boulders, many of which we try to climb. And the rounded shape of these rocks indicates prolonged abrasion as they collided and rolled downstream. Sediment transport occurs differently depending on particle size. Fine sediment can remain suspended in water while larger rocks move by rolling or bouncing along the creek bed. When water slows and loses energy, deposition occurs, forming gravel bars and floodplain sediments. So here there's a picture that shows a rock bed with rounded boulders, and you also get to see gravel bars or something that looks similar to a gravel bar, which is just bar like longitudinal structures or structures in a water body that are made out of gravel and are formed due to sediment deposition. Let's move on to eroding and mass wasting. Or flooding and mass wasting. So, we do know at this point that daily river flow or the flow of water in a river causes erosion and changes the landscape. But that's not the only kind of water flow that can create change. Massive events like flooding, where there's an insane amount of water that is flowing at a higher speed, events like these can accelerate geomorphic change. In our field trip, we saw again the large boulders deposited above the normal water level. We also saw fallen trees and flood debris and dry flood channels. These features indicate past floods that were high energy and were capable of transporting massive amounts of sediment and woody debris. Flooding greatly increases water velocity and thus has a lot of erosive power. Flooding and this also accelerates channel change. Mass wasting, including slope collapse and bank erosion, also contribute to additional sediment to the creek. Now that we've discussed all of these different processes that have and continue to change the physical landscape of the Lynn Canyon Park and Suspension Bridge, I would also love to discuss how the valley has not only changed over the past few years, but continues to do so because of many geomorphic forces. So let's start with the ongoing evolution of the landscape. Here you can see a diagram of a river terrace, which I will explain in a second. So river terraces are benches or elevated flat surfaces which represent a former level of the valley floor. They form when hydrological or climatic shifts cause a stream to cut downward into its floodplain, leaving the old floodplain elevated above the new level. Here you can see the T1, T2, and T3 are all the elevated surfaces, also called the river terraces. These elevated flat surfaces above the Lynn Creek are the river terraces and represent former valley or floodplain surfaces that were once at the level of the creek but were abandoned as the river continued cutting downward. At one of our stops, we observed larger trees, which was stop 7, where we observed larger trees growing on these higher surfaces, while younger flood tolerant vegetation occupied lower elevations near the creek. This indicates that higher terraces no longer experience regular flooding because they're at an elevation. These terraces are evidence that Lynn Creek continues to incise deeper into the landscape, showing that the evolution of this physical landscape or of this field site is still very much ongoing. And to conclude my presentation, we'll just run it back and go through all the different forces that we've discussed that shape Lynn Canyon. So there's 6 major processes that we discussed. Number one being glaciation that created the original valley, sea level change that altered drainage patterns, river erosion and downcutting or fluvial erosion that carved the canyon, sediment transport that redistributed or redistributes material to this day, deposition that forms gravel bars and floodplains, and flooding and mass wasting that um, accelerate change and cause like massive changes in the physical landscape. And here's our references. And thank you so much for listening to our presentation.